Flack math! Give me some math and I'll give you some flack. Flack math!
We're going to do 75 and 76. Pretty simple today. Shouldn't take too long, so I won't keep you too long here. So we already know how to find the area of rectangles. You remember base times height, or just length times width. And we know how to find the area of triangles, which is basically base times height divided by 2. So it's like half a rectangle. So if we know how to find the area of a rectangle and a triangle, then we can pretty much find the area of anything we want. So for example, here is a weird shape. Let me make that a little bit longer. Okay, so if I wanted to, I could make 2 shapes out of this, right? Well, first of all, let's give some dimensions here. Let's say this is 10, this is 16, this is 4, and this is 7. Okay, so I could make 2 shapes out of this, right? Look at this. I don't know how to find the area of that weird looking shoe, but I do know how to find the area of this rectangle, which is just 7 by 10. So that's a 70 square unit rectangle, right? And then this guy, let's see, what are the dimensions here? Well, we're going to have to do some subtraction here. If this is 4 and this whole thing is 10, that means this has to be 6. So if this whole thing is 16 and this part is 7, that means this is 9. So then let's see, base times height divided by 2 is 54 divided by 2, which is 27. So this guy is 27. So the area is just going to be this rectangle plus this little triangle. So that's just 70 plus 27, which is 97 square units. So far, so good. That's pretty doable, right? Okay, let's try something a little bit more complicated. Not too complicated, but a little bit more complicated. So here's example 2. Boom, 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 boom. Oh, this looks bad. So let me just kind of redraw it here. Ignore that part. That's embarrassing. I don't know what that is. Okay, so let's see. Our dimensions are 10, 6, 3, and 10. Any idea how we can find the area of this weird looking thing here? It looks like a Superman symbol, kind of. That's a little off kilter. So I'm going to get my blue pen out and draw some shapes. Any suggestions? I could just do this. So there's a nice 3 by 10 rectangle. And then I could do this. And then I've got 3 shapes that I know how to find the area of. So this is 30. Any argument there? This is 30. Okay, now what are the dimensions here? This is not 10. So if this is 3, this has to be 7. So this is 6 times 7, which is 42. Everyone okay with that? All right, so this is a 7 by, let's see, if this whole thing is 10 and this is 6, that means this has to be 4, and that's 7. So let's see, that's 28 divided by 2, which is 14. So the area is going to be, add all those up, 30 plus 42 plus 14 equals 86. And let's say they're centimeters. All right, so far I'm not really feeling like this is too difficult. Are you? Does this feel okay? Okay, so this leads us to a shape that you already know. This is a trapezoid. A trapezoid can look like this, where it just has 2 parallel sides. Let me just mark Avery here. Where'd she go? Oh, she's already here. Okay, So this is called a trapezoid. So if you have two parallel sides here, then it's just a trapezoid. You just have one pair of parallel sides, that's a trapezoid. Now, unfortunately, even if they give us units like this, 10, 7, and then let's say the height is 6 here. Well, you can't just make another triangle here because you don't know what this length is or this length is. But what you could do is you could make two triangles this way. If I went like this, then that makes two triangles, right? So how do you find the area of this triangle? Well, that is going to be base times height divided by 2. So that's 7 times 6 divided by 2, which is 21. Okay, and how do you find the area of that triangle? Well, that's base times height. Base times height divided by 2. So that's just, sorry, there's guck on my tablet. So this is 10 by 6, to 10 times 6 divided by 2, which is 30. So if this is 21 and this is 30, then my area is going to be 51. Okay, now there's another way to do this. Wouldn't it be nice if I could shorten, if I shorten this 10 a little bit, if I shorten this 10 a little bit and I shorten this 7 a little bit, then I could have a rectangle. Okay, so that's another way to do this, where if I just found halfway between 10 and 7 and then did that. So if I shorten the 10 a little bit and I lengthened the 7 a little bit and I went halfway between 10 and 7. Anybody know what halfway between 10 and 7 is? Let's see, that would be 8.5. Okay, so if I found the area of this, it would just be 8.5 times, no, yeah, no, yeah. Oh yeah, times 6, right? Because that's just a rectangle. So what? Guess what that equals? 51. Okay, so an area of a trapezoid, if you want to write this down, you can. So halfway between, do you guys remember the fast way on how to find halfway between two lengths? You just find the average. So these are the two parallel sides. So if I find the average of the parallel sides and then multiply by the height, that's the area of a trapezoid. But if you forget that formula, no problem. You can just make two triangles like we did here. You can just make two triangles out of a trapezoid and you're done. Okay? So that's how you find the area of a trapezoid. And if you forget, no worries. You just make shapes that you know how to find this area of. Okay? The other thing you could have done, let's draw this trapezoid again. Very poorly. This is 10, 7, and this is 6. What I could have done is I could have put these two triangles together. So if I put these two triangles together, like right here, then this is going to be still 6. But if this is 7 and this is 10, then this has to add up to a total of 3. So I could have found the area of this, which is 7 times 6 is 42, plus this 3 by 6 triangle. 3 times 6 is 18, divided by 2 is 9. So 42 plus 9 is also 51. So you could have done it like that too. Put the two triangles on the end together and find the area of that one triangle, and then you're left with this rectangle in the middle. You could find the area that way too. So if you don't know which way to do it, then I would do it all 3 ways. And when you take a test, you should do it 3 different ways if you can, because if you get the same answer all 3 times, then you probably did it right, okay? So that is lesson 75. Are there any questions on 75? No questions? Okay, so somebody just arrived here. Who's here? Okay, sorry, 1 second here. Okay, so I'm not seeing, so I have an Yvonne. Who's Yvonne? Is that you, Marin? So I just see a parent's name, but I don't know parent's first name. So I'm gonna assume that's Marin. So I'm gonna go do that. Hey, is that you, Marin? Are you Yvonne? Okay,
Yeah, sorry, it won't let me choose my username. I don't know why.
that's all right. Now I know. Okay, so let's just mark you here. All right, moving on. So that's 75. Let's move on to 76. Okay, so 76 is just, it's called complex fractions, but I don't think they're that complex. Because a complex fraction is just a fraction within a fraction. Okay, so let me tell you an example, like 3/5 over 2/3. So see how these are this is a fraction within a fraction. So this is like a fraction of a fraction, which is weird. But a fraction is just a division symbol. It's just a division problem, right? That just means divide, right? So this is just 3/5 divided by 2/3. Well, how do you divide fractions? Copy dot flop. Copy dot flop. So 3/5 dot 3/2. Okay, multiply across 9/10. You're done. Go home. That's fine. You are home. Never mind. Okay, so a complex fraction is just a division problem. You're just dividing fractions. No problem. Let's try another one. Let's see if we can make this hard. I don't think we're going to be able to do it. I think we're going to fail at making this difficult. Here's example 2. 25 2/3 all over 100. Well, copy dot flop. Well, first of all, what do we think of mixed numbers? Do we like mixed numbers in division problems? No, we think they're dumb. No offense. Mixed, yes, actually, you can take offense to that mixed number. You're dumb, okay? So let's change it to an improper fraction. So 3 times 25, that's 75 plus 2. So 77/3 all divided by 100. Well, you can't divide fractions by whole numbers, so make that whole number a fraction, just throw it over 1. And really what you're doing is you're making 100 an improper fraction too, aren't you? When you put it over 1, you just make it an improper fraction. So we're going to copy dot flop because that's what we like to do, and that's how you divide fractions. 77/3 dot 1/100. Okay, nothing cancels, so you're just left with this fraction. It's not very pretty, but it's the answer. Okay, so far so good. Okay, I'm going to try 2 more things, and I'm going to try to stump you, but I don't think I'm going to be successful. So see if you can do this one on your own. This is example 3, and here's the problem. See if you can do that one. While I take 3 sips of coffee. Okay. That was the third sip. All right, you guys keep working. I'm going to catch up. So first thing I see is this dumb mixed number. We don't like you. So that's 21 plus 1 is 22 thirds. So this is 15. We don't even like you. 15 over 1 divided by 22 thirds. So that means this 15 over 1 divided by becomes dot. Flop that 22 thirds to 3/22. Nothing cancels, so you're left with 45/22, or 2 and 1/22. Okay? Is that what you guys got? Sweet.
Yeah, I got that.
Adeline, did you say no?
I got that too.
Oh, you did? Okay, good.
Me too.
All right. I'm going to try one more. Can you guys handle it? And then we're done for the day. So let's try this one. Let's change 83 1/3% to a fraction. What? Well, how do you change a percent to a fraction? Do you remember how to do that? So see if you can do that. This is a good one. I'm going to give you a little hint. If you're stuck on how to get started, here's a hint. 78%. To change that to a fraction, you throw it over 100. And then you reduce. So with that in mind, see if you can change 83 1/3% to a fraction. A nice reduced fraction. This is a good one. It's clever. Uh-oh, somebody's printing something. What's happening? Illusions in Old Man in the Sea. That's what somebody printed. Did you guys read Old Man in the Sea? Have you read that? That's a good one. Good one. Someday. All right, I'm moving in. So to change any percent to a fraction, you throw it over 100. 83 1/3 over 100. Anyone want to share their answer before I share mine? Just for fun. You can chat it, or you can say it. Up to you. Where is my chat? There's my chat. So that would be, the decimal would be 0.83 repeating, Kiara. Good job, but we want a fraction. So let's do it. So first of all, remember, we don't like improper fractions. Pooey on you. So we're going to change that. Let's see, that's 249 plus 1 is 250 thirds divided by 100. So times 1/100th. Okay? So we just copied, we dotted, and we flopped 100. When you flop a whole number, you put 1 over that whole number. Okay? So I can do some cross reducing here, or you can just multiply across and reduce later. But what goes into all this? Well, it looks like 50 goes into all this. So if I take 50 out, I get a 2 and a 5. So multiply across, 5 times 1 is 5, 3 times 2 is 6. So the answer is 5/6. Let's see if someone wrote that. Yeah, I'm not seeing it in chat unless somebody else chatted me privately. I don't know. But that's it. So this just became the same kind of problem we were doing before. You just got a mixed number over a fraction. Technically, that's a complex fraction. So just divide it, copy dot flop, and you're good. All right, any questions on that lesson? Everybody good?
I didn't know how to spell 5 6.
Well, the number 5/6 works.
Oh, okay.
All right, so that's all I got.
Black math, give me some math and I'll give you some flack. Black math.